All right, so for today, I will be talking about three different. Oh, there's somebody with a microphone on. David, could you turn off your microphone, please? Thank you. Okay, so we will be looking at three types of data for today, or two types of data. It is GeoPandas data and raster data. And then third, we will be looking at working with Folium. So we're looking at three different methods to work with geospatial data and information for today. I'm going to start off with downloading some packages we need. OSMNX is a really famous one. I don't know if you are familiar with OSM. OSM is an organization that collects a lot of road data and makes it makes it available, and it works together with Networks X, which is another open source Python software. They collaborated to make really available road data. Something else we are working with, I think they're not that relevant except for GeoPandas. And that's the first thing we will be looking at. All right, so I've downloaded all the packages I need now. And we'll first be looking at GeoPandas. And a little note before we start, this lecture is inspired by 3 blog posts from Parvati Krishnan, and they're all listed here. And you can just click on them, and then it takes you towards the website. So if you're curious to read a little bit more, you can always follow those links. All right, so GeoPandas. I don't know if you have been taught about pandas. I think you might have already. It doesn't really matter. I think you're all familiar with Excel, right? Pandas is a method, is like the Excel of Python. It allows you to make those big raster frames like Excel sheets. And it gives you a very insightful way to work with your data. So I just looked at some Dutch data that I found online. Oftentimes you can find the GeoPandas data online. So I just forgot to mention. So as Pandas is like the Excel you can work with within Python, GeoPandas is specifically made for geospatial data and allows you to work with like roads or different shapes of administrative boundaries of different countries. So, and oftentimes you can find this online. So I found the data for the Netherlands on the website of the, in English it is the National Georegister. And oftentimes you can find like a zip file like this, and then you just do copy link, and then you can download it within GeoPandas. So you do geopandas.read file and then input your data like this, and then turn it into a geodata frame. So first we're downloading the municipal boundaries here, and I've made a separate data frame for Amsterdam. I'm all gonna show and explain this a little better later. And then secondly, I'm downloading the road data for Amsterdam. So I'm using OSMNX for that. And I'm using the function features from place, and I've inputted Amsterdam here. And then let's have a look at how this data frame looks. So I run it twice. Sometimes downloading data from the internet gives you some weird warnings, but when you run it again and it doesn't show again, there's no problem there. So here we see, this is the data frame. As you can see, it looks a lot like an Excel file, right? So it has different rows, they contain information, and each row has different columns. So in this case, we have a certain code for the administrative boundaries of the place we're looking at. We have the name of the administrator of the municipality, and then we have a geometry column, and this is the geospatial column that shows the that will give you the shape of the administrative boundary. So to start, say we want to look at Amsterdam, then we take our NL bounds data frame, or so that will be like this, and then opening squared brackets, we can make a certain request. So we put NL bounds dot gemeentenaam, which is the name of this column, and then we say it has to equal the name Amsterdam, for example. And then here we get out the row for Amsterdam. And then we can, for example, look at the shape of Amsterdam. In that case, we would do NL bounds dot log 50, and then we do geometry. And then this is the shape of Amsterdam. So this is like the geo shape of it. Now, another thing, sometimes you can't immediately find what you're looking at. So for example, I wanted to find Den Haag. And it doesn't show, but it should be in there. So I wrote a little code here. And for now, I would just say, in case you want to use it, just change the name in here if you want. What this little piece of code does is it finds for you the coordinates of Den Haag and then finds the row in the data frame. So here we see now that Den Haag was saved as Schravenhagen, which is a different name for Den Haag. And the index number is 231. So if we do, if we do NL bounds.log 231, we get Den Haag. And then if we do geometry again, we get the shape of Den Haag. So that is a little starter on the on how the GeoPandas data frame looks. Are there any questions about this already? Are you, is it a bit overwhelming since you have not had any pandas, or is it okay?
What packages are you using?
Sorry?
What packages are you using?
Yeah, so I'm using GeoPandas, and
GeoPandas.
I installed it using this command, and then of course
nice.
import.
Import
and then,
is alright.
Sorry?
I know nothing. I'm just reading out loud. Sorry, I'll mute myself.
Okay.
I have a question.
Sure.
So if we want to sort of run the same script, we'll do it in this collab file itself, or will we have to sort of download it and install Python on our local system and then run it? How does it work, if you could
It
explain
depends
that
on
bit?
what you want. I think for smaller problems, working in Google Colab is nice because it just works well. You don't have to install anything on your own computer. It contains a lot of packages, and it also Google Colab also makes it easy for you to share your code with somebody else. So I think actually for the projects you're going to do later on, it might be really nice to work in Google Colab. I see another question in the chat. Is this works good? And then a picture. I am not sure what is going on in this picture, actually. I would just go to...
This is device on screen.
Sorry?
I downloaded device on screen. It was like this. I noticed it's different between yours and this one.
Okay, yeah, this looks like you're running something in a terminal. So I'm actually not sure. I think you can, I can share the link again in the chat. If I can find the, let's see. Here we go in the chat. And then, didn't copy properly. And then you can run it there yourself. But I would only start playing with that maybe at the end of the lecture. And for now, just look at what is going on. well, I'll run this. So anyway, this is with regards to the, oh, now I'm downloading it again, but it doesn't really matter. So anyway, this is downloading a geodata frame from a file. And then what I did here in this line as well is download a road network for Amsterdam using OSMNX. So that is this code. What is really nice about OSMNX is that you can just give a name of a place you are interested in. So in this case, I wanted to look at the road data from Amsterdam. I think it's still downloading because I accidentally hit the run this cell thing again. So I think we'll have to wait a tiny little bit for it to download. But this also downloads as a GeoPandas data frame or a geodata frame. Sorry that it is a little bit slow. Okay, so it's been downloaded now. So let's have a look at that data frame. Here we are. So again, we have all these different rows. We have one a column talking about the highway, which is the type of road it is. So we have a cycleway, very Dutch. We have a pedestrian way. We have a footway. We look at the name. So these are the names of the street. We have the Zeeburgerstraat, Vondelpark, Osdorpplein. Then we have a column talking about if it's bikeable or not. And here it says yes, and I don't see a no, but it should also say no. There are also a lot of non-values, which mean that it doesn't have any information. So for some of the data, sometimes it doesn't have all information. Then there's a column max speed. We only see nones, but this max speed shows how fast you can drive here. And then again, we have this geometry column again. And I'm just going to look at the geometry for a random road. What we saw for the administrative boundaries is that we get like two-dimensional shapes called polygons or multi-polygons. And for the roads, we get lines, so line strings. All right. Now, maybe it's nice to also look at what type of data we have. So, for example, highway, we see a lot of different highways. And it might be nice to see what type of highways we have. So we do roads, AMS, and then we do highway, and then we do unique. And then it makes a list of all the unique highways we have. So here we see it. We see that we have cycleways, pedestrianways, footways, steps, living street, residential, unclassified, secondary, tertiary, primary. This has to do with what type of road it is. This information, I should have included it in the slides, but if we look at OSM data highway, we can find all this different information. So if we see, for example, the value motorway, then it is a restricted access mayor divided highway, normally with 2 or more running lanes. Here we see.
So unique gives you all the variables that can go into the cell.
No, it gives you all the inputs that are in a different cell for
Right.
So
all the potential inputs for a variable.
Yeah, exactly. So in this case, now we just look at our whole column, and then if we do .unique, we see here a whole list of it. And we can do this with different columns as well. So let's look at bicycle, for example. After bicycle. Then we see that it contains a lot of things. It contains a non-value, which means that it doesn't know. And then we have a yes, a no, and then we have designated, dismount, use, side path, permissive, a bit of some vague information. This is also the information you can find in here. And generally on the OpenStreetMap wiki, you can find what most information means. So if we're going back to highway, this column, then this is the like all the roads we had. So and then here we can kind of figure out what that means. So yeah, I'm looking if I can find, for example, Living Street. We have that here. And then here we see Living Street. So for Living Streets, which are residential streets where pedestrians have legal priority over cars, speed are kept very low. Just to make sure that you have this website, I will put it in here. There we go. So we have all this data and it's really nice to visualize it. So to start us off, I want to plot the road data of Amsterdam. In that case, we take the name of our geodata frame and we do .plot. And if I run that, sometimes it takes a little while. But here we see all the roads of Amsterdam. They're all blue. There's no extra information about it. We just see the shape of it. And we also see that here are just a lot of streets really close together and it becomes one blue blob. But, well, we can make that a bit easier for ourselves if we can put in here line width is 1. And they might become a bit smaller and it might become more visible. Okay, it became a little bit more clear, right? Where the roads are. Maybe we can do 0.1 and then it's more obvious what is going on. Here we go. But the smaller we make the roads, the vaguer they get, of course. So this is how we can look at this whole road data. But as we saw in our geodata frame here, there's a lot of information that comes with this data frame. So what if we wanted to plot the data and make a distinction in the type of highway it is? Then we can tell the plot function which column we wanted to distinguish between. So we do column is equal to highway, and then the rest I will explain a little bit later. But for now, I'm just going to show you how that looks. I think it's easier to explain what is going on. So here we are. So now we see the road data of Amsterdam again. Wait, make this a little smaller. All right, we see the road data of Amsterdam again, but we see it has different colors. And we see that, for example, bridleway, busway, construction, corridor, cycleway, and elevators are all in different shades of blue. We see that red can be a footway or living street. We have dark orange that is a motorway, which is kind of, I don't know if you're familiar with Amsterdam, but there's a big motorway running around Amsterdam here. You can already see that is orange. Yeah, so in case we kind of wanted to make a distinction between what kind of roads there are, we can make that using by indicating the column. And then now looking at this CMAP means what type of coloring we're going to use. So if we Google Python CMAP, and we're using matplotlib for that, then we can find this type of website. It's not this one. Sometimes I also use this, and then it gives us different names for it. There should be so for example, you can find a lot. So for example, if we were to use flags, then it uses this color, or prism, it uses this color. There are also different sets of colors like this. So for example, if I input pastel 1 in here, then the colors will change. takes a little bit to run. See, now the colors are different. So if you're going to play with this, you can also play around a little bit with the different colors. And you can just Google them like this. Next thing I wanted to talk about is the size of the figure. If we just input fig size is something, as you see, like this picture is much larger than this picture. So if we would have made this a bit smaller, we could have done 10, 12, and then it becomes smaller.
Is this pixels or centimeters or?
That's actually a good question. I generally just play around with it a little bit until I understand or until I see a size that is large enough. I don't think it is centimeters because screens have different sizes and it will have a different size on different screens. And I also think that this is a bit larger than 10 centimeters. I think they're just a certain unit here. Okay, anyway, then the last thing I put in here is legend is true. And that if I put the legend on true, it will show me this thing here. So far, so good. We're gonna play a bit more with plotting different things. Namely, as we saw before, we have this maximum speed column here that has a lot of non-values, but surely also different unique values. Wait, I will show you max speed. So we have none, but we also have all these different numbers here. So I thought it might be nice to actually plot some of this information. So here I've plotted it, or here you see the data frame where max speed doesn't have a non-value. I can filter this out by looking at, or by opening the brackets and then typing roads Amsterdam.maxspeed.is null. That will give me the columns with where the max speed is null. And then if I do this little squiggly line here, it gives me the ones where it's not null. All right.
Can you repeat the part of filtering the data with a specific thing like the none?
Yeah, okay. So essentially what we do is if we do roads of Amsterdam, so the name of our geodata frame dot max speed dot is null, or like if we do only max speed, we get our column. And then if we do dot is null, it will give us a true if there is a none value in our column and false if it's not. Sadly, we don't see that here because all the ones here, as you can see, they were all none. But yeah, so these all turn true. And now if we have a column with true and falses, and we put that in between brackets, and then we put the name of our data frame, then here it has filtered out, or now it's only filtering the ones with the max speed is null. And then if we do this squiggly line, wait, I think it's easier to show you like this. Okay, so we just had this column, right? Where we get all these true values. Now, if we put this little squiggly line, it turns all the trues into falses and all the falses into trues. So if we put around that these square brackets, then it just takes all the ones that had a true value. And because this gives us a true value, if there is a value in max speed, we get the data frame with all the values that are non-filtered out. So, I mean, we could also do that, for example, with bicycle. And then here, there are no none values anymore. See? So, or we can do that with name. And then here, we only get the roads that have names. But I wanted to have a look at the max speed column. because I think it would be nice to see, to plot this information and showing how fast you can drive on different roads. So there are two ways to go at it. Wait, I'll move this down. So here we go. So here we have our two figures, and I've plotted two because there are two different ways to do this. So again, I can take just my data frame and I do dot plot. And then I say my column is max speed. The CMAP I want to use is cool warm. That goes from blue to red. I'm including my legend. And then because we had all these non-values, we need to do something with these non-values as well. So here I put missing KWDS is, and then I say the color of this is light gray, and the alpha, that is the opacity of the line, is 0.25, because I want that to be filtered out a little bit. And then we get this first image here. Yeah, if I, for example, change this to blue or pink, maybe, then it's easier to see. Then all the roads that had a non-value will turn pink. Here we go.
What do you mean by the missing KWDs?
Yeah, so as we saw there, this max speed column had a lot of non-values, right? Like all these values were none. So we need the, when we plot this function, we want this to look a bit differently. Because I mean, if we do like, if we do roads dot plot column is max speed, and then we take CMAP is like cool warm. Well, it now also gives, it generally puts the non-values in gray, but if we want to give them a different color or make them less intense, using this alpha function, then they're also, yeah, then we can alter that a little bit, is kind of the idea. So if we, yeah, if we only run this like that, then we get a lot of gray values for the, or actually it doesn't plot the non-values. And if we do want to plot those, but give them a different color, we can plot them like this. We can also make them invisible.
Can we give them white to be invisible?
Sorry?
Can we make them white to be invisible? Or
Yeah, you can put the alpha to none to make them completely invisible. So
not the whole, just the non-value.
Yeah, exactly. Okay, yeah, so as I said again, sorry for the little mix-up. Now I've made sure that all these non-values are invisible, and then we get a little gray that's like in between the red and the blue. So that's a little bit of a mix-up.
So essentially what you're doing is filtering out and displaying only certain roads from what I gather. Am I right?
Exactly. And in case we do want to include those roads, we can give some information about those roads in here. So I could have also turned them yellow and then made them really bright. Like this. See, now all the roads that had a non-value are yellow. And if I put this alpha to 0, then they become completely invisible. There we go. Now, this is one way to filter out those roads entirely, but we could also just look at the data frame where all those null values are completely filtered out. So as I, let's see, showed here, I'm going to delete this one. So here, with this little piece of code, we can filter out all the rows that are that had a non-value for the max speed. So we can also just plot this data frame, and that's what I did in the road below. So that's this. And then I also input, and then if I do column is max speed, CMAP is cool, warm, and legend is true, then I get the second photo that keeps on generating, because this piece of code generates one of the plots, and this piece of code generates one of the plots. So the plot we get here is the bottom one. And as you can see, because with the top one, I've set everything, I've set the non-values to 0. They look exactly the same. So these are two ways to go at it with non-values. Then next, I thought it'd be nice to look at the roads that we can bike on. So as I showed before, we have a lot of different information with regards to whether you can bicycle on a certain road or not. And if we want to make like a clean column of that, we can do it like this. So what I'm going to do, I'll run this separately. So first we're going to make a whole new column called bicycle clean, and we make all the values a non-value, and then it looks like this. Here we go. So here's our new column. And now for all the elements of that column that had the bicycle that was yes, so maybe I'll take it separate so I can show you a little bit before. So look, here we're filtering out. So using the .log is in this case the same as this. So anyway, now we're filtering out all the roads where we can bicycle. So here we see that this is all yes. And then if we type no here, it's all no. And if we want to, and now we want to, in bicycle clean, just put yes or no here. So in that case, I do road.amps.log and then take this bicycle is yes. And tell it that our bicycle clean column will have a true value. And for all the ones where bicycle is no, we want it to say false. So I'm going to run that, and then you can see the column. Here we go. So now this is the data frame we get. And indeed, we can see that if it was a none here, it gives a none there. If it is yes here, it gives a true there. And maybe, let's see if we can find in the head the top 15 entries, whether there was a different value. Sadly, I can find a different value, maybe in the tail. At the bottom, no. Okay, so I can't find the cases where there was a different value. But if it would have said like bicycle is go to sideway or something like that, then yeah, it would have also given a none value for that.
Do you need the step of first creating the bicycle clean column with all nans? Or is it just for
It
clarity?
depends. So in this case, I wanted it to plot the data where I just know whether I can bike on a road or not bike on a road. And for everything, and I did want to show all the other roads, but I wanted those to be light gray. So here you see the, so here I've plotted this. I refer to my bicycle clean column. I use the CMAP going from red to yellow to green. You can find it on these different maps here. And then for the non-values, I wanted them to be light gray and have an alpha of 0.25, so a very low opacity. And that gives me this figure. And
yeah, but so if you would just like not
if I wouldn't make
like
that
if you don't really define it beforehand, but you just say, okay, I want in my new column bicycle clean, if it's yes, I want true. If it's no, I want false. Doesn't Python then by default give all the other rows nan, or it doesn't work like that?
No, it doesn't work like that. So it will
Okay.
give everything a different color. So if I just do roads Amsterdam dot plot column and then is bicycle, then it will give all these different values a different color. So
Yeah, but I mean, if you don't expressly define your bicycle clean column to exist out of to have only nan values before you start assigning trues or false, but if you you have the data frame road amps, and then you just say, okay, in this data frame, I get a new column bicycle clean. If like you just start assigning the trues and the falses, does it then what happens? Because I would expect then by default that all the rows that are not either yes or no would get a nan by default, so you don't have to really like define that beforehand. But I don't know if it actually works like that.
As I showed you before, if we do roads amps dot bicycle dot unique, then we see that there's a lot of clutter in there. So it contains nones, it contains yeses and nos, but it also contains it contains designated, customers, private, unknown. And that's vague information. And we know that if there's a yes, then certainly you can bike there. And if there's a no, then you cannot bike there. So that's why I created a new column, the clean bicycle column. And I just said, if we know that it is a yes, we want it to be true. And if it's a no, we want it to be false. And everything else, we just want it to be a nan, so a value we don't really know.
Yeah, I just wonder what happens if you omit that first line. So you just start assigning. So you don't have the road amps bicycle cleaners float nan. If you just comment that out, and then you just start running from.
Yeah, you mean
there.
that if I would have done this, so let's do bicycle clean 2, it might actually do that. Oh yeah, it does actually do that. So in theory, you don't need this first line.
Okay, perfect. Thanks.
Yes. Anyhow, I thought you were aiming at what if I don't clean it, and then we see here we get a picture with only the labeled roads, and it's quite a mess. It's quite
super unclear.
Get our information out. So that's why we create this really somewhat clean one. All right. So another way, a third way to go at it is to plot multiple data frames in here. So we can have 3 data frames. So here we have a data frame where our bicycle column is either yes or no. Or wait, here we have a column where it's not yes or no. And then we plot that and we make it light gray. And we add our label for our legend called status unknown. So wait, I will plot this one just as is, and you can see how it looks. So I plot it like this. There we go. So these are all the roads that have for the bicycle column, not a yes and not a no. So we plot this as a basis. And then the second row, we plot all the ones where bicycle is no. We remove this. I will explain the subplots later. So these are all the no roads, and I made them red, and I labeled them not bicycle roads. I will get to labeling later. And then lastly, the green roads where you can bicycle. Oh, I keep forgetting to remove the X like this. Here we go. And
Are
then
we going to merge them together?
exactly.
You know, and yes one. Okay.
We're going to put all these pictures in one picture, and we do that using the subplot command. So we have plt.subplots, and we need to make one figure and one, it's the X. I actually don't know what the word for it is exactly, but this X here we need to include it in our plots. So this is that x is x. If we include that, then all these 3 lines will be part of the same plot. And then we add different labels to these plots. And then we can add a title like this to our plot. And by plt.legend, it will make a legend of these different labels. And then if we do plt.show, it shows us the whole figure. And it will look as follows. There we go. So here we see also in the legend, the gray one's status unknown, and then we have not bicycle roads and bicycle roads. And here's our title, do roads have bicycle lanes? Okay, so what I did in the beginning is make a third data frame only of Amsterdam. So remember we had those boundaries. This is what I showed you, this little shape of Amsterdam, but I've actually just made a little data frame of Amsterdam, like so. Oh, now I've removed it. Okay, so I do Amsterdam is NL. Yeah, here we go. Amsterdam is equal to NL bounds, and then gemeentenaam is Amsterdam. So now I wanted to plot the administrative boundaries of Amsterdam together with our roads in Amsterdam, right? So initially you'd say I'd combine those two. So if I plot this, I will get an error, and I will explain to you why that happens. Oh, I was supposed to get an error here. Okay, it doesn't really matter. So we see the administrative boundaries of Amsterdam here, and we see the roads. What I actually wanted to explain to you now is the coordinate reference systems of a geodata frame. So we've all heard of coordinates, right? Like latitude and longitude. These all, this is very important for a data frame because then it knows what to translate all of these things to. So if we do our data frame.crs, it will plot our different CRSs. And here we see that these are the same. So they're both the same code, right? So I don't know what I accidentally ran, but they were supposed to have different CRSs and then show you why this goes wrong. But they both have the most standard coordinate reference system. But what was supposed to happen is that the roads of Amsterdam had the EPSG of the Netherlands, but I can still change that, and I will show you how. So let's get back to it. Okay. So say we want, I put down somewhere here what the Dutch APSG is. So this is the Dutch one. So say we wanted, or I think it's easier to do with the roads. It's a bit annoying that this didn't work the way it was supposed to work. So if I want to change the CRS, I run to CRS and it returns to me a changed CRS, and I do, and I just assign that to a new data frame. Let's call it roads Amsterdam to size is this. And then if I were to run this, our picture would have looked like this. So here we have our roads, and somewhere else really tiny is our, it's most likely here, is our administrative boundaries of Amsterdam. And then if we print the CRSs, we see that they are different.
Can you repeat this step?
Okay, so
Slowly, yes.
Okay, so what I kind of wanted to show you is that if you work with the geodata frame, then this geodata frame has a coordinate reference system. So how to translate these coordinates. And I think we all know latitude and longitude, but there are different coordinate reference systems, and these allow us to, for example, like if you take the distance between 2 points in on the globe, then this distance is not the real distance. And changing these CRSs allow us to use change these shapes and therefore preserve these distances. But there are different coordinate reference systems for different cities or for different countries. It depends on how large the country is. Generally, the universal one is 4326. And this is the one that doesn't preserve distance for anyone or for any place. But for the Netherlands, we have a CRS of, it is 28992. And if we use that, then the length of our roads will be preserved. So if we look at roads Amsterdam to size, look at this. I'm just going to open the data frame and then we do dot geometry dot length. I think it works. I saw polygon in there. Then we see like some roads are 2 kilometers, some roads are 163. Oh, this is actually meters. So this is like 3 meters. This is 164 meters, 52 meters, etc. And that helps us with doing a lot of calculations. Yeah, and I think now I will use this roads Amsterdam to size. So if you want to change the coordinate reference system of a certain place, then you use 2CRS. So now we had this data frame containing the boundaries of Amsterdam, and I want to set it to the true size of the Netherlands. And then if we run this, it will be the same size again. Oh, sorry. I needed to use this one. And now it is the same size. So roads Amsterdam is in the general coordinate reference system, and roads Amsterdam to size. And now also, since we ran this command, also Amsterdam is a true size. And we also see here on our y-axis and our x-axis, we no longer see like smaller numbers between about 0 and 100, but we see quite long, large numbers. And this is to preserve this distance. Does that clear things up a little bit? Or are you still confused?
For me, it's clear, I think.
It is a bulk of information, but we're trying to catch up with you.
Okay.
Okay.
Okay. So as I showed you before, now we can easily calculate the distances of our roads by using geometry.length, and then it returns this to us. So now if we look at our old roads amps, .crs, this had the general CRS. I will print it. I think that will be more clear. Then it will just be short. Now it gives a lot of information. Here, this was this 4326. This our old data frame before we converted it to the Dutch coordinate reference system. Now I made this function for you to calculate the kilometers of length of road. So say that we have a CRS of this, and we quickly want to calculate the length of a road in kilometers. Then you can use this function. The only thing you need to look for is that you choose the correct EPSG. So as I said before, the coordinate reference system for the Netherlands is 28992. and I've included a link to the website where you can find the EPSGs of other countries. So it is epsg.io, and then say, for example, you want to find the coordinate reference system of Chad, search, then generally you can find one that works. So for example, for Chad, you could use this one, or if you wanted to use one for or for Mexico, for example, then you find it here and you find the code. And then you can do 2 CRS and you can use this code to transform this data to the local distance preserving coordinate reference system. And then you input that here, and then it generates for you the length, the kilometers of length of this road. So running this, it provides, so you input your whole data frame, you do calculate kilometers length of road, and then it returns a column, so you can immediately assign it to a column, roads Amsterdam or roads Ams. And then if we return this, we see here, we have a new column called kilometer length. And then, for example, we can calculate how many kilometers of road there are in Amsterdam. So we just do roads Amsterdam dot kilometer length dot sum. And then we find that there are a little over 5.5 thousand kilometers of road in Amsterdam. All right. And then we can plot this data using roads Amsterdam.plot. And then again, we do a column is kilometers length, and we set the legend. So here we see, well, most of our roads were quite short. So this bar kind of indicates how long the roads were. So if they're really dark blue, then they're really short. But we see that like more yellow roads have a long kilometer. So here we see some roads that are a bit longer, right? So that's how we can calculate distances and plot distances. This is most of what I wanted to show you for GeoPandas. Maybe it's nice to do questions about GeoPandas for now. So is everything a bit clear? I can understand if you haven't worked with pandas before, which I'm actually a little bit surprised about, given that it should be part of this fellowship. Then I can understand that it's very overwhelming what I just explained. So yeah, feel free to ask me any question.
Hello.
I can hear somebody, but you sound very robot-like. Am I the only one who can't properly hear this person?
I can't hear.
Okay. Is it
either.
possible for you to type your question in the chat? Oh, I see a lot of questions in the chat. But please type your question otherwise in the chat and I will read it. I also see there was a discussion about why we use Python for geographical data. Python is just a very commonly used language. And a lot of people have developed open source software for Python, and it's quite simple to use. So that's why we've been working with Python. Yeah, I think this was most of the discussion. But the person that just wanted to ask a question and didn't have a well enough connection to be properly heard. How can I plot multiple subplots if I want to compare maybe the evolution of bikeable roads? So what do you mean by the evolution of the bikeable roads?
Britt, I have a question regarding this pattern. As you said, this is a library for language programming.
Mm-hmm.
And as you said that we are using currently the GeoPandas,
Mm-hmm.
and volume is also part of this Python language programming or not?
Sorry, what is part
I
of
said
it?
that I said this GeoPandas that
Mm-hmm.
we are using currently. Is it not possible to use volume as well?
Oh, you mean the area?
Exactly, like if we have both libraries
Mm-hmm.
and we use the GeoPanda as a
Mm-hmm.
process the data, and for visualizing and the results, we use the volume for interactive mapping.
Yeah, yeah, that's a really good question, actually. So if we look at our NL bounds data frame, so we have polygons. So for a line, generally, you have a length, but for like different shapes of areas, we have polygons. And if we have, let's check the CRS we have for this one. Okay, so for our NL bounds, we had the a CRS like the universal one. So if we change this to the Dutch CRS, so this was 28992, if I'm not mistaken. 28992. Then it returns a data frame with these shapes changed. And if we then do dot geometry dot area, then we get the area of our different administrative boundaries. So that kind of looks like this. Yeah, this is a bit vague maybe. So I could do NL bounds area, make a column, area of the municipality, and close it again. And then if we look at our data frame again, then we see here the size. So let's see the size of Amsterdam. I think Amsterdam was 50, right? Let's have a look. Yeah, this was Amsterdam. And then we do area municipality. And then we see that it is, and this will be in meters. So it is about 220 million square meters. So yeah, for lines, we use dot length, and for polygons, so like two-dimensional shapes, in that sense, we do dot area. Does this answer your question? All right. Any other questions? Are we ready to move on to raster data? Amazing. Okay, so the package we're going to use for raster data is Rasterio. You can download the packages with the pip installation. We also need to import requests. I will show you later what we're going to use that for, and we're going to import NumPy. All right, so the data I will be working with is the population data for the Netherlands. I'm using the data from World Pop. If you would want to use this data or also download this data, I've made I made a function for it here. And you just need to input the URL of the data. So to show you how we can find that, we go to the World Pop website. It takes you to this part of the World Pop website, and then say we wanted to download the data for, I'm just going to do the Netherlands for now. It is this data. We click on, we click on data and resources, and then we scroll down, and then here it gives a button, download entire data set. You can download the entire data set, but what you can also do is right click, copy link, and then input that in here. So this is the same link here. So yeah, if I'm pasting it, it is exactly the same. And I run this download world pop from link piece of code. And this is why I imported request, because you need it here. And now we have downloaded the data. But raster data is a bit confusing, because if I just show you how this data looks, it is super confusing, right? Because we see these arrays with a lot of values in it. It's not very clear what's going on. So if we want to plot this data, then we use this little piece of code. There are different layers of data, like as you can see here. Yeah, I read the first layer. The first layer contains the population data, and now, oh, I did a keyboard interrupt. So if I run this cell, so I made a new variable called NL-pop total, and it's the reading of the first layer. I set some parameters for the figure size of the figure I wanted to plot, and then I use plt.imshow and then NL-pop total, and then I added the color bar here, which shows the population density, and then here we see our population. But the large problem we have is that all the points where there was no population are minus 99,999, and our population doesn't weigh into that. So our color bar is mostly huge minus signs. So that's why plotting this data is sometimes a little bit difficult, but we can definitely grasp a lot of information from this data. So we would want to filter out these really like large negative numbers that don't contain any population. So we do that by using our NL-pop total is larger than 0. We save that to new variable non-zero Netherlands. And then, well, first of all, we can calculate all the population we have in the Netherlands. So we do NL-pop total, and we input the population that is larger than 0, so non-zero Netherlands, and we sum it. And then we see that there are 17.35 million people in the Netherlands. This is data from 2021, so that's why it's not 18 million yet. But that's how we can calculate our total population. So why do we only look at this data? As I said before, like we have a lot of these minus 99,999 values. Yeah, so that's why you have to filter that out. And then let's have a look at the CRS of this data, because this data also, of course, contains a coordinate reference system. And we can grasp that by taking the original file, so not the total population, but just the original file, .crs. And we see that it has this universal CRS. Now, say we want to go back to our data frame with the administrative boundaries for the different municipalities, and we want to read our, we want to see per municipality how many people are living there. Then I wrote a little code here, and I can imagine if it is a little bit confusing. But what I'm doing here is I'm using the geometry of our NL bounds data frame and trying to get the population. And I just have to check, because I just played around with these CRSs, if my NL bounds is still in the universal CRS. Yes, it is. So this won't give me any issues. So anyway, I ran this code. I used an apply function, inputted this function that I won't explain for now, and added it to a population count column. And now I can plot my NL bounds data. So wait, I will show you where I have the new column. Here we see our population count. And then if we plot it, here we see the total population of each municipality. And we see that this bar is no longer doing weird things, so to speak. So this is like 0. So the bluer values have a lower input, and then these higher values show the municipalities with a lot of population. And as you can see, this is Amsterdam. And of course, the most people live in Amsterdam. And then this is Rotterdam. This is The Hague. So these are all very busy municipalities. And that's why all the others are pretty blue. That's most of what I wanted to say with raster data, because what it is easiest to usually translate, because raster data is so, I would say, messy, as we've seen so far. It's really nice to just take from your raster data and put it into a geodata frame, so it's information that you can actually work with a little bit. So that's most of what I wanted to explain for raster data. Are there any questions about this? Okay, I'm just going to move on. The last thing I wanted to talk about is folium. And
There is a question in the chat.
oh, sorry, I didn't check the chat. How can I change the CRS of a raster object? I have been having an error that it is read-only. Oh, I don't know what you ran exactly, actually, but generally, don't try to change the CRS of your raster data, because that is generally impossible. Change the CRS of the data frame you're working with to the CRS of your raster data, and then take that information from it. Okay, got it. Good. Okay. Are there any other questions? Just to check the chat. I also see the question, what about GeoMap? And I don't work with GeoMap, and generally, I actually don't have experience with it, but it's not a very commonly used one, for as far as I know. That being said, I'm going to move on to folium. Oh,
The last
yes.
one. Why would I prefer making or generating maps with Python instead of others?
Instead of?
Of other programs.
Well, because Python is just has a lot of like options you can do. So like there are different. So you were just talking about ArcGIS, right? Or QGIS or not?
Yes.
So like QGIS is a certain program, but it doesn't allow you to do a lot of like computational calculations. So for example, in my research, I use a lot of geospatial data, but I also use a lot of heavy mathematics, and Python allows me to combine this with each other. So I use, for example, Gurobi to optimize certain problems, but I do this on geospatial data. So that's why it's really convenient to use Python, because I can both like work with my data and clean it up and shape it into a form that is useful for me, and then use Gurobi in Python because it allows me to optimize this data. So that's why we are talking about using GeoPandas in Python as opposed to using QGIS.
Can I make a little question?
Of course.
I'm interested, I'm not into too much of this geo information. It's everything new. But yeah, I'm interested in the future to plot a card of all the foreseeing in my bike, and I want it to be dynamic and to look like in the dashboard, so then you can have different layers and plot the different things. The person itself can choose which layers they want to plot. I am like a owner here in the bike X, and I want to know what are the amount of schools, or yeah, something like that, like a Google Maps, but I wanted to use it, yeah, commented data. So my point is like, can I do these dashboards, and how can I do this in an interactive way for the user? So
Yeah.
it's not just a picture, but a person can choose and click different layers and yeah, to plot what they want.
Yeah, so I think a lot of like school data and other like building data can be downloaded from OSM. And I actually mostly talked about the roads because generally we work with roads, but I know that you can also download this data from OSM. And well, I just haven't got this prepared for now, but I can send it to you. I also know that Parvati has written a lot of code where you can download this data. And of course, you can also find it on the website, and then you just download it to your computer and open it as a file. But this data will also for sure be GeoPanda's data. So that's why
Uh,
you need to know.
yeah, and
GeoPandas.
yeah, so just really nice, but how do which interface can I use then to, for example, I want to plot and I want a person to be able, a person that is not me, a person that is someone who is like a dashboard. How can I plot this in a dashboard that then you can choose, oh no, I want to see schools today, but tomorrow I want to see just the days for the daycare, and
Yeah, so
that
for
plotting
example,
crossing with, for example, kids who have achterstand in the taal achterstand, something like that. What's the name of this? When they cannot, yeah, they have a
Like
achterstand in the taal.
interactive.
Yes,
Can
where
we
you
make
can plot
interactive? Yes.
different variables at the same time and see gaps.
yeah,
And not me, because I am the researcher, but the end user, that can be a civil servant, that can be a normal person that doesn't know these things. That I can make the back part, but I mean, usually give something to a product to someone, and they can do their own analysis with that.
yeah, that's a very interesting question. What I know about this, but I really don't know a lot about this because this is more about creating an interface than working with different types of data. But you can do this with HTML, and then, but yeah, I don't have experience working with HTML, but you can use HTML to then and build a website in HTML and then run this in the back. And then in that way you can make an interface, but I can't help you any further than that for now.
Thank you so much. No, it's okay. Good night.
But I understand that you would like to do this, and I think it's actually really interesting to do. So maybe I will write it down, and it might be a
Yes,
part
please,
of
because that's my project.
Yeah.
Supposedly that's my project. And yeah, I was thinking I'm gonna do it in Power BI with Power BI and ArcGIS there, but I realized I was too limited, and then I was like, what can I do?
Yeah, no, I understand. Yeah, I'm sorry I can't help you with that for now. But I think also Parvati has experience working with this. So if you want to do this for your final project, I would definitely ask if you can work with Parvati to make this. Okay, nice. Okay, then the last thing I wanted to talk about is Folium. And Folium allows you to plot very nicely different types of data, and also allows you to download different types of data. So first of all, we're just going to plot a map of Amsterdam using Folium, and then you can use this little piece of code. You use geopy.nominatim user agent. This isn't all that interesting, except that we input Amsterdam here, and then we tell Folium to plot this, show us the map with these coordinates of Amsterdam as the location. And then if we plot that, here we go, we see Amsterdam. And it just shows us the map. So we're not per se downloading data, we're just visualizing this, this map. And I think, if I'm not mistaken, OSM or the maps of Folium run on OSM data as well. All right.
Can you copy the code to the chat?
I am going to share this whole.
Okay.
I also put this this whole collab file in the chat, so you can open it later and look through it entirely.
Okay.
All right. So we've run that. Now, if we want to combine our the GeoPandas data with this map, I wrote a little code for that. So this allows you to add a data frame or a geodata frame to your Folium map. So what you're going to do is, I would say I'm going to centralize my map around Utrecht. I'm creating the map here. And then I run my little code at the geodata of my NL bounds. And then I show the map. And then it shows me this. And then I can zoom out a little bit. And here we see the administrative boundaries, so the different municipalities on the map. So I'm not going to explain to you how this function works, but you can always use it. All right. And we can also use this, for example, to plot our roads data. And then we just do, I'm going to put this to Amsterdam again, and then we're going to add our roads of Amsterdam. And then if we run this, it plots the roads of Amsterdam. Sorry, it takes a little while. Oh, I think this is why I chose to show you the bounds as opposed to the road data, because it takes so long. Oh, I already included it here. Okay, I'm just gonna make sure this stops running because it takes too long. So what I did here is I filtered some of the roads out and just took some of the more serious roads and not like pedestrian roads. So we would have a smaller data frame and then plotted them together. And I think now it will go a bit faster. I hope it is almost done. Should be showing the map by now. There we go. So here we see all the more motorway roads on the map of Amsterdam from our data frame. All right, then the next thing we can use Folium for is to actually get certain locations. So what I'm doing in the next cell is I'm going to create a little geodata frame with these different locations. And it's going to contain the name of the location, the color of the marker, the longitude and the latitude, the country it is located in, and the city. And I've created some data here. So first of all, the place I want is the University of Amsterdam, the Spoorwegmuseum, which is in Utrecht, the Efteling, which is a really big amusement park in the Netherlands, National Park de Hoge Veluwe, which is a beautiful nature park, and the Keukenhof, which is the place where you can see tulips. So this is like the places I want. Then I added the cities these are located in, and then I gave them a different color that I want to give them. And then I've created this function for you, these two, called create location data frame. So I'm gonna run that, and I have to input my data like this. So the like place, the city it is located in, and the color I want the marker to be on the map. So here I have my data frame. As you can see, like it contains these different addresses, or I called it addresses, but you can also call it the name of the place or something like that. The city, the color, the country, the latitude and the longitude. And now I'm gonna make a map of these places with the different markers on it. And again, I created a little function for that. So first I'm gonna find the center of the Netherlands. So I'm using this GeoPy again, put Netherlands in here. I'm creating the map again here, and then add markers from the data frame to the map. And if I run this, then I get these different markers. And that's how you create a map with different markers on it. So this is not, sorry. So we can use like GeoPy and the functions I've provided for you to actually get this information from online and create our own data. And then we can use this information that we got from our online to plot things in Folium. Are there any questions about this?
Can this be done with like addresses as well, or only with
You
site?
can run this with addresses, like yeah, we can. I mean,
Yeah, just give like the street and the number, and then it would work.
yeah, generally this works, but sometimes it's a little unpredictable because first I wanted, as opposed to the Spoorwegmuseum, to the Nijntje Museum. But let's say we change this to the address, so Plantage Muidergracht, number 12. That's the university building I'm in currently, which is in Amsterdam. And then we create our new data frame, and then here we see our address. And we get the latitude and the longitude. Do check if it works, because sometimes it can't find it because you're just inputting a name. Anyway, and then we can plot this again. So I'm just gonna copy this and post it here, and then you can see. Here you go. So now here, this is Plantage Muidergracht, number 12. Yeah. Any other questions? Okay, apparently not. This is all I prepared for you today. I hope it was a little bit useful. I can imagine if there's not a lot of experience with pandas, then learning about geopandas is a bit overwhelming. But there's a lot of like online resources to learn pandas, but you should also learn it in this course, if I'm not mistaken. So
I think it was one of the preparations we had to do. So
okay. Yeah.
we should have seen it.
Okay. Yeah. Yeah. Also, when creating this course, I assume that you knew it, and therefore also knew functions like unique and filtering out certain files. So, yeah.
Thank you.
Yeah. Yeah, if there are any other questions, I'd be happy to help. When it comes to doing projects for you later, I would love to help you out with projects along these lines that include like optimization of geospatial data. So definitely hit me up for that. Yeah,
One
and
question maybe.
Sorry?
One question. Have you done your analyses in Python and then used the output into Power BI ever, or have you never done that?
I have never worked with Power BI in my life.
Okay. No, that's okay. Just curious.
How can we extract this work?
Yeah, I shared, but I'll share it again. Share the link of this Google Collaboratory in the chat.
I mean extracting only the map as a picture. Yes.
Yeah. So if you just want to extract the map, this is the first cell here. Yeah, so you don't even need to use GeoPy as long as you kind of know the coordinates of where you're looking at. So let's say we want a map, and then yeah, what if we just do 0.0? I think we end up like at the Ecuador below London, then we just get a map like this. So you use this to create a map and then plot this map. Okay, so let's do a start zoom of 5 on this, then it should be zoomed out. So then here we are in the center of the coordinate zoom. So yeah, if you know your coordinates, you can just input them here and then plot it. So yeah, what if we do 10 and 5? I have no clue where we're going to end up. It might be in the middle of the sea. Here, Africa. And then we can play around with the start zoom. So we can also do 1, then we get a really big map. See? And if we use like 3, we zoom in a little bit. So that's how we can play around with this. And then you can use the later functions to include like data that you might have or extract some information. So yeah, I hope this helped. I was also asked if I could take a little screenshot from the people who attended this course. So I'm quickly going to do that before all of you leave.
Smile.
It's quite a long, sorry you have to stay here for this. But then at least we know everybody that's present. And then, yeah, if there are any other questions or also love to hear if this inspired you to do a certain project that you didn't think was possible.
I have one question if I can go ahead with before we finish.
Yeah, of course.
I'm actually a mentor, but since I love, I used to work a little bit with the geospatial data. That's why I joined today's session. I never worked with, let's say, Python for geospatial data. I was working mostly with quantum GIS, with Tableau and stuff like that. But I'm very curious, like, because I hear now that most of you guys, you already know what are the projects you're going to work on in the nearest future, in a couple of weeks, actually, from now. Do you know, Britt, or any of you, like, do we have already this information? What are the possible projects? What is being, let's say, foreseen for the next couple of weeks? Because we know we are going to become officially the mentors in around 10 days, 2 weeks from now. But I'm very curious, like, to know whether we already have the list of all the projects being specified. So let's say if somebody really loves working with geospatial data, is this matching of the mentors and fellows happening like with the discussion with the mentors, or is it only like internal discussions of all the people organizing the program?
Yeah, I'm not sure how it's organized this year, but what I know is that people are going to propose different projects, and we are all going to be sent these proposals, and the fellows will also give a preference for which mentor they want.
Okay. Mm-hmm.
And then the mentors, of course, can choose who they want to mentor.
Okay, so there are some, this matching, let's say the matching session is going to allow us a little bit also to discuss further, okay, the projects and ourselves. Okay, nice.
Yeah,
Thank you
and
so
of course,
much.
if there are interesting projects that need different types of knowledge, like two mentors can also work together.